We're just swimming in a sea of data and claims every single day. But how do you sort through all that noise to figure out what's really going on? Well, statisticians have this incredible tool, almost like a superpower, called hypothesis testing. And today, we're going to break down how you can use it too to separate what's real from what's just, well, fiction.
I mean, you hear stuff like this constantly, right? Some car company drops an ad with this huge promise about how efficient their new truck is, but is it for real?
Or how about this one from the world of education? A tutoring company says, hey, our method helps 90% of students get top grades. I mean, that's a pretty bold claim, and it's one that could make a lot of parents and students spend their money.
And then you've got the corporate world making statements about average salaries. Now, what do all of these have in common? They're all specific claims about a much bigger group, or what statisticians call a population. So, yeah, that really is the big question, isn't it? When you're hit with all these claims, how can you figure out what's likely true and what's not? We need a system. And that system, that formal investigative framework, that is exactly what hypothesis testing is. This isn't about gut feelings or guessing. Think of it more like a courtroom trial for an idea. It gives us a structured, step-by-step way to look at the evidence and actually make a logical decision.
Okay, so every good investigation needs a starting point, right? And in hypothesis testing, it all begins by setting up two completely opposite statements. These two ideas are basically the foundation for the whole shebang. All right, first up, we have what's called the null hypothesis. You'll see it written as H naught. The easiest way to think about this is that it's the boring reality. It's the status quo. It's the idea that nothing special is happening. No change, no effect. In that courtroom analogy we mentioned, the null hypothesis is the defendant, assumed innocent, or in our case, assumed true, until the evidence says otherwise. And then, arguing against the null, you have the alternative hypothesis, or HA. This is the exciting new claim. This is what the researcher is actually hoping to prove. So if the null is the defendant, the alternative is the prosecutor's case. It's the argument that says, hey, the status quo is wrong. There is something going on here.
And here's the most important part. These two have to be polar opposites. They can't overlap. So let's go back to that truck. The null hypothesis, the status quo, would be the truck's average mileage is exactly 35 miles per gallon. And the alternative? It's simply that the average is not 35 mpg. See? Complete opposites.
So how do we decide which one is right? I mean, we can't test every single truck that ever comes off the assembly line, right? That's just impossible. So what do? Just like a detective, we gather evidence. And in the world of statistics, our evidence is our sample data. Okay, now we get to a really key piece of evidence. It's called the p-value. And honestly, the best way to think about a p-value is as a surprise-o-meter. It answers a very specific question for us. If we assume the original claim, the null hypothesis, is true, just how surprising are the results we got from our sample? And this brings us to a super helpful little rhyme that statisticians love. If the p-value is low, the null must go. Basically, if your p-value is really, really tiny, it means your results are incredibly surprising. They're so unlikely to have just happened by pure chance that it's like having evidence beyond a reasonable doubt. And that surprising evidence gives us the power to say, you know what? We reject that original claim. Okay, so we've set up our case, we've gathered our evidence, we've checked our surprise-o-meter. Now it's time to deliver the verdict. We have to make a decision. But, and this is so important, just like in a real trial, there's always a chance, however small, that we could make the wrong call. This table lays it out perfectly. There are 4 possible outcomes here. 2 of them are great. If the defendant is innocent, the null is true, and we acquit them, awesome, correct call. If the defendant is guilty, the null is false, and we convict them, great, another correct call. But those other 2 boxes, that's where we get into trouble. Those are what we call statistical errors. So, a type 1 error. This happens when we reject a null hypothesis that was actually true. To go back to our analogy, this is a really big deal. It's like convicting an innocent person. Our evidence seemed strong enough to reject the status quo, but we got it wrong. And then you have a type 2 error, which is the exact opposite problem. Here, we failed to reject a null hypothesis that was actually false. This is like letting a guilty person walk free. The evidence just wasn't strong enough, so we completely missed a real effect or a real difference that was there the whole time. So you see, this whole framework, from setting up these opposing ideas, to gathering evidence, to understanding the risk of being wrong, it is an unbelievably powerful tool. So let's zoom out and see where this stuff actually gets used in the real world.
Yeah, this is absolutely not just some boring thing you do in a stats class. I mean, businesses use this every day to figure out if a new ad campaign actually boosted sales. Medical researchers depend on it to know if a new drug works better than a sugar pill. Educators use it to see if a new teaching style is actually helping students learn. It is literally the scientific engine that drives decision-making pretty much anywhere data is involved. And really, that brings us to the big takeaway here. Hypothesis testing isn't just a series of steps you follow. It's a whole mindset. It's a way of thinking critically about the world around you. So I'll just leave you with this question to chew on. What's a claim you hear all the time, or maybe even a belief you have yourself, that you'd be willing to actually put to the test?